Hello everybody. It's been a while since I've done any videos on the channel, and I thought I would just do one today. We're bringing back some old technology. Some of you will be familiar with this. You may notice that it's sitting up on its side, but there is a reason for that. It's just to make it a wee bit easier to show you. It's sitting with a stand behind it. And I have got the lights off. The reason I've got the lights off, they're the LED lights and they tend to buzz a little bit. So I'm going to show you how this circuit can actually be quite massively improved. Let me just remove that capacitor out of the way, and it wants to fall down, as it does, of course. Always the same when you're doing something. Just let me just put something else behind it, just to hold it in place so it doesn't keep falling over. It's easier to do it this way, to be fair, to show you what I'm doing here. So anyway, okay, that's us back. So the initial kit, R1 was a 680K and R2 was a 4700 ohm. And we have an AF116, we have an AC126 and another AC126. So in this case we are using an unknown one. It's a CV, I think it's for something or other, I can't quite read it, I'm doing that, 76 or 7609, I think it is, which I don't know what it is. Can't find an equivalent for it. It could be any of the AF ranges, and it's I've got a pile of them here. They're all new, and they don't have don't have tin whiskers, which is very unusual. Anyway, so the circuit is a reflex circuit. So basically, what's happening is the transistor amplifies the RF off the tuning circuit, which is your ferrite rod and your coil and your tuning capacitor here. So basically what it does is, like it says, it amplifies that, but it also does a double roll. If you notice the way that this is wired up, you'll see that the diode, the detector diode, right, feeds the audio back through the secondary winding of the it's basically got two windings, this coil. It's got the main tuning coil and it's got a pickup winding, just 2 or 3 turns on it, and going back into the base. So it's amplifying the RF, and it's also amplifying the audio, and so the audio is picked off via the RF choke. So the RF choke basically kills the RF coming in, and you only see audio here. Now, the actual initial circuitry is fine, but there's, like I say, there are quite a few things on it that improve it quite considerably. We could drive the transistor slightly harder, not a lot harder, but you can. You can change that to a lower value, and in this case, I think we've got 3.3. I really need to have my glasses on. Okay. Yeah, no, I can't really see that, to be fun. Anyway, it's dropped down. I think it was a 3.9K or something like that I put in there, if I remember rightly. It does help if I've got my specs on, which I don't have. I changed the 680K to a 270K. And this 0.1, which is basically for filtering, I actually reduced that quite a lot to I think 4,700 picofarad. It came down as much as that. Also, the coupling here, which is a 0.1, it's better actually with an electrolytic in it. I just kept that, so there's a 1 microfarad in there, and again that makes a big difference to this very, very simple 3 transistor radio. The only snag with it, of course, is it's really in some ways a bit like a crystal set. They tend to bleed across the stations, but as we know now, the medium wave is beginning to die a death. There's not much here, and there's only 3 stations that are of reasonable strength that we can hear here. So I'll show you what it does at the moment. As you can see, there's 2 stations mixing.
All the young stock move across the country and down into England.
But what we don't get is, although we can try to get to Talk Sport, we get 5 Live coming across it because they're close. So what do we do about that? We either dismantle it and build another project. We think about what we can do to improve it. And we do things that maybe Mr. Phillips could have done with it, but in actual fact didn't. But no doubt he was down to try and do things quite simply. Increasing the gain in the audio amplifier doesn't help us. It doesn't help the bleed through from the other channels. But what would do, in actual fact, is to improve the Q of the tuned circuit. And you think to yourself, well, how can we do that? Well, we can do that actually very simply. How we can do it is we can put some positive feedback from this stage back into that coil. And that really increases the Q. And of course what that does is that also brings up the gain considerably, and it makes it much sharper to tune. Now all we need to do is get a little bit of feedback from this stage. So we've got a winding here, as you can see, this extra winding, just loosely coupled. We've got a 47 picofarad capacitor, and we've got it the other end of it going to, well, it could go there, it could go there. It's irrelevant where it goes. It's basically earth, ground. I know what you're saying, that's not ground, but you've got a capacitor in there, so a big capacitor. So we don't need to worry about that. So I'm going to try and put this on without pausing the video. I'm going to put that capacitor in here. If I can see what I'm doing, that's one of the problems I have, is actually seeing. Getting to this age in life where things are not working quite as good as they used to do. Now whether or not that's touching or made a contact is another story. Anyway, we'll put it back on and we'll see what it does. Right, you can hear it, it's oscillating. It's oscillating because there's too much feedback, so we need to reduce it by uncoupling it a wee bit. Now look at the difference now. Look at how sharp that is.
Oh, I spun around to tell my wife. Presumably you spun around and what was your wife standing there?
That's one station.
You know, when I started doing research, I would
There's
watch
another
all
station.
these clips from, you know...
The incident stabilised.
And there's a strong one, Radio Scotland. So we've now separated them all out. We're able to pick out all those different stations that that are transmitted. And that's because we have increased, if you like, the total efficiency of the tune circuit by feeding a portion of the signal back into that coil and back in, into the ferrite rod and into the coil, which increases the Q of the circuit. So that is why we can tune that nice and sharply. We can play with that, give it a little bit more by moving that coil up slightly, but we've gone into oscillation again.
Now, a new creative trade forum is being launched by the UK government to help create.
So it's too tight and it's very sharp.
The best of British.
So, basically, I was trying to find a way to kind of...
And it's quite loud.
There's a very strong, like, you know, the very...
I think the clubs in Scotland need to take more responsibility, work together.
So what we have now, we have a TRF radio, reflexed, and also with what they used to call back in the old days a reaction. So that transistor is actually, this single transistor is now doing three things. It's amplifying the RF, it's amplifying the audio, and it's also producing feedback into that circuit here to increase, as I say, the Q, the gain, and the selectivity of that stage. And just by a couple of turns of wire and a 47 picofarad capacitor. That's all. It's as simple as that. Now, when Philips brought these kits out, it was to inspire you. It was to get you into electronics. It was to get you to do things that were magic at the time. Transistors weren't long about. All the stuff beforehand was done with valves, and you needed higher voltages. Maybe for a youngster, 10, 11-year-old. And this wasn't aimed at 10 and 11 years old, right enough. But when I got mine, I think I was 10. And I have to say that it was an opening for me for electronics. So, like I say, experimentation. So where do we go with experimentation? We could do like I did very late in life. I was, let me think, I would have been, when did I do this? I was about 68, 69 when I passed my foundation licence for as a radio amateur. Thereafter I did the intermediate and the full. But what is radio amateur? What is being a radio amateur all about? Well, yeah, we talk to people, we put up antennas, we buy radios and so on and so forth. But that is not the main purpose of being a radio amateur. The main purpose of being a radio amateur is experimentation and learning. And although this is old technology now, you still learn by this. And this is one of the beauties of groundwork in electronics, going back to, if you like, its roots. I'm not telling you to go back and look at valve technology. Yes, you can, by all means, you can go and look at valve technology if you wish. You'll learn things out of that, and to be fair, it's not something that is taught these days. And there's still amplifiers made for audio. There's a lot of valve linears around still these days as well for RF. And I mean, valves are quite good to play with. You can make a one valve radio and actually get surprisingly good results. But again, of course, we're losing the AM transmissions on medium wave. Shortwave isn't anywhere near as busy as it was when I was a youngster. And now, at 72 years old, well, it's changed days. We have all sorts of different other things on the go these days. We have digital modes. We have FT8, which a lot of people say it's a digital mode. Technically, it's not a digital mode. It's an analog mode. Because what happens is the system produces audio tones. They don't produce digital tones. They produce audio tones that vary in frequency that can be decoded either in the radio's firmware, like on the Zygo X6100 using the alternative Russian firmware, or on your PC with a program called WSJTX, but there are others. Doesn't need to be connected to the internet. The internet has got absolutely nothing to do with it. So there are many things that people should be doing, or we would like to think they would do, to learn more about electronics and how radio works, and how you can make an electronic organ in this. You can make a flashing light. I mean, this might sound very basic, but I mean, you're using the transistors as switches. You're learning how a transistor can work as a switch, and so on. So all very good groundwork. So, guys, if you've got an interest in electronics, start with the basics, ask questions, go from there, and if you're really keen on it and you're young, take it up as a profession or become a radio amateur. You know, there's so many things that you can do in that hobby. It can be an expensive hobby, but it doesn't have to be. There's lots of second-hand equipment around. There's lots of projects that have been on the go for years that you can make, and that's how you learn. Anyway, guys, I just thought I'd show you this and what you can do with a very, very simple circuit like this to actually make it better than it is, by the addition of one capacitor and changing values here and there to actually improve the way that circuit works. Philips, at the time when they did this, they did it for a reason. They didn't want to overtax the transistors. They didn't want to somebody land up with a failure, especially a kid, and then be upset because their prized possession didn't work any longer. But of course, don't forget, with stuff like this, you're taking it in and out of circuitry, metal fatigue, wires get broken off transistors, and so on and so forth. And it makes you wonder how many of these were probably binned because of that. But I was very fortunate to get this one earlier in the year, which is complete, and that's very, very unusual indeed. Been great fun. Thoroughly enjoyed working with it. I am considering you can do this according to Philips' book. You could rewind it for what they call the Troller band, which today we would call that, it's near enough top band, the 160 meter band. And we could, of course, rewind that for 160. And this circuit, believe it or not, with a bit of positive feedback, you could hear SSB transmissions on top band, and you would also be able to hear Morse. So again, all these things you can do. Thanks guys for watching. I hope you've had a great time and a great day. All the very best. Cheers now.